The ATS Medical Open Pivot Mechanical Heart Valve has a pivot designed to be more open to blood flow. It is the only bileaflet valve that eliminates cavity pivot recesses and is uniquely engineered to minimize the thromboembolic complications of mechanical heart valves. As described by Virchow's triad, all mechanical valves are challenged by physiologic factors impacting the interaction between blood, materials, and flow characteristics. Mechanical valve surfaces quickly become coated with blood proteins, to which platelets may adhere. These platelets form the basis for future thrombogenesis, as they can subsequently become activated due to flow conditions. In this sequence, we zoom in to actual SEM photos of pyrolytic carbon, showing the surface both pre- and post-exposure to blood, illustrating the actual adherence of platelets. Blood flow at the edge or boundary encounters the non-moving carbon surface of a prosthetic valve, slowing the flow near the surface that can create shear stress sufficient to activate the adhered platelets. High-velocity flow, turbulence due to flow separation, and regurgitant jets increase shear stress that can result in platelet activation, which, when combined with areas of stasis, provide opportunities for activated platelets to aggregate. This blood-prosthetic interaction, resulting in non-physiologic blood flow through a mechanical valve, is the primary reason mechanical valves require anticoagulation. The blood interaction with mechanical heart valve pivot design is critical to valve performance. Managing flow quality, especially through the pivot, is the best way to minimize potential clot formation. Bileaflet cavity pivot recesses, used in all but the ATS open pivot mechanical valve, have long been held as a potential source of thromboembolic complications. These cavity recesses require scraping by the pivot ear and flushing by high-velocity leakage jets to avoid the accumulation of thromboembolic components. Improving the design of the valve pivot provides the best opportunity to reduce this inherent weakness. The open pivot has positive relief pivot points, rather than the indentations of the typical cavity pivot design, eliminating the pivot recesses as a potential area of stasis and source of thromboembolism. The open pivot heart valve leaflets float on spherical protrusions and are retained in place by leaflet stops. The open pivot is designed to be more open to the blood flow, resulting in a gentler, passive pivot washing in both forward and retrograde flow. Studies have shown that, compared to the flow through the open pivot valve, cavity pivot valves result in higher shear stress. Regurgitant jets used to wash the cavity pivots are high velocity, cause high shear stress, and create more turbulence. This activates some of the platelets and is believed to be the major cause of mechanical valve thrombogenicity. A key study by Dumont et al. Examined regurgitant flow. This is a comparative video from their computational fluid dynamics CFD particle flow simulation. Note the broader, lower velocity flow through the open pivot when compared to the narrower, longer, higher velocity jet through the cavity pivot.